alright. طيب احنا المحاضرة الماضية بلشنا نحكي عن الكينولونز وإن شاء الله اليوم رح نكملهم. Our next subject رح يكون البنسلينز، يعني حتى يعني even though we will be finishing early today بس ما رح نبلش في البنسلينز. البنسلينز رح نتركها للمحاضرة الجاي، يعني ما بدي أبلش اليوم بجزئية وأرجع أعيدها المحاضرة اللي جاي. هلا uploaded على الاي ليرنينج كل ماده البيتا لاكتامز، بنسلين، سوفالوسبورينز، مونوباكتامز، وهي تقريبا we will spend almost let's say 3 weeks on those subjects. Already عشان احنا we do not need to spend a lot of time regarding the mechanism of action of this huge drug class. نزلت لكم على الاي ليرنينج an animation for the mechanism of action which explains what target those drugs bind to, the structure of the cell wall and so on. طبعا أكيد رح نحكي عنه في بداية المحاضرة الجاي، بس يعني لما أحكي عنه رح أعتمد أو رح أكون let's say مفترضة إنه already you do have some background. أنا mostly اللي رح أركز عليه ال variations ما بين الcell wall for gram negative gram positive، لأنه هاي ضرورية later on في الoptimization للبيتا لاكتامز to broaden the spectrum of activity. برضو كمان how this process occurs exactly أو how the synthesis of the cell wall occurs exactly، لأنه بناء عليها رح نعتمد على كيف نفسر those beta lactams acting أو binding to those targets. فرجاء المحاضرة اللي جاي تكونوا at least let's say مطلعين على الفيديو عشان somehow تكون الباك جراوند لما نشرحها عن السيل وول synthesis تكون واضحة بالنسبة لكم. طيب هلا before I let's say finish the structure activity relationship for quinolones اللي بلشنا فيها المحاضرة الماضية, let me very quickly let's say summarize what we have discussed last lecture. أنا بعرف إنه بالنسبة لكم إحنا already we've seen this structure أو we've seen let's say the drug bound to its target وناقشنا بشكل مفصل عن الانتراكشنز اللي بيعملها وبناء عليها you can predict إيش changes without memorizing them. You can predict إنه إيش changes اللي may retain the activity and what those that may lower or diminish the activity. بس لأنه المحاضرة الماضية كان في مشكلة بالمايك ما سجلنا لهم إياها وsuch let's say خلينا نحكي details ما شرحنا لهم إياها أو ما كان في مجال إنه أسجلهم إياها فأنا مضطر أعيدها. فيعني bear with me. إحنا يعني حكيناها أو شفنا let's say the crystal structure before بس يعني I will go through it very quickly. طيب هلا what you are seeing in here اللي هي a fluoroquinolone و in particular اللي هو called ciprofloxacin bound to DNA gyrase and DNA. Okay, حكينا المحاضرة الماضية إنه a very very crucial interaction that ciprofloxacin أو fluoroquinolones أو حتى to be more let's say accurate الquinolones in general form with their target اللي هو coordination with the zinc which is أسفل manganese which is let's say highlighted here or colored here in purple. هلا these coordination bonds that the oxygen of the carboxylic acid اللي موجودة عندي على carbon number 3 بالciprofloxacin والoxygen of the carbonyl اللي موجودة على carbon 4. Okay, these interactions are very very crucial. Anything that will lower the strength of those bonds, anything that will prevent one from binding or coordinating with the manganese will definitely lower the binding affinity أو حتى كمان it may diminish the binding of those quinolones with their target. Okay? Meaning إنه إذا أنا بغير for instance the carboxylic acid into something that does not ionize at physiological pH or may not have the same electron density, الactivity بتقل عندي بشكل كبير. Anything that will change the geometry. يعني لاحظوا إنه أنا عندي هاي let's say the pyridone ring, all right, where carbon 2, 3, 4, all of them are sp2 hybridized بمعنى أن geometry around them is planar. وبرضو كمان carbon of the carboxylic acid is sp2 hybridized with geometry for it is planar. Meaning لو أنا عملت rotation in here لاحظوا إنه كل هاي atoms of this ring along with the carboxylic acid والcarbonyl اللي هي behind the carboxylic acid كلياتهم على نفس البلين. The planarity of the two oxygens in here is very important for efficient coordination مع المنغنيز. Anything that will change the geometry, such as, for instance, reduction of the carboxylic acid into an alcohol, reduction of the carbonyl in here into an alcohol, for instance, رح تغير الجيومتري بحيث إنه okay, those two oxygens will not be both planar مع المنغنيز. Such change معناها إنه لو وحدة من الأكسجينز كانت قادرة إنها تعمل coordination مع المنغنيز الثانية رح تكون بعيدة. Alright? Such changes will definitely diminish the activity. Same thing for the double bond اللي موجودة ما بين carbon 2 and carbon 3. Okay? Which positions the carboxylic acid والكيتون planar to each other. فإذا أنا بعمل reduction لهاي الدبل bond, the geometry of this carbon in particular بتغير. الكربوكسيليك اسيد بدل ما هي تكون بلانر مع الكيتون ممكن let's say تتغير الزاويه اللي هي موجوده فيها inside the binding site of the target, meaning that okay it will be far away from the manganese. Another thing which is also very important اللي هي الinteraction that this carboxylate forms with serine. This, let's say, amino acid in the DNA gyrase, which is serine 1084, that's the sequence number for this amino acid. هلا هاي السيرين is forming an ion dipole interaction with the carboxylate. فبالتالي, if I would, let's say, change the carboxylic acid into something that does not ionize, such as مثلا an amide, an aldehyde على سبيل المثال, alcohol, any of those functionalities will eventually lead إنه ما رح يصير في عندي strong hydrogen bond interaction مع السيرين, which will also يا إما يقلل or it may diminish the activity. Now, if you look at, this is something we've discussed in the previous lecture of carbon 6. شو موجود عليها? Based على color code here. Fluorine, okay? لاحظوا إنه أنا عندي الفلورين, if I would zoom out, it's forming interactions with the nucleic base that is on top of the fluoroquinolone, okay? And let's say one of the amino acids, which means, this is also another nucleic base, which means that this fluorine is forming very good binding interactions, which is part of the very high binding affinity of this drug to its target. فبالتالي إذا شيل الفلورين into something different, الأكتيفيتي عندي راح تقل. وبرضه كمان ناقشنا في المحاضرة الماضية إنه when they added fluorine to carbon 6, the lipophilicity of the drug increased, which led to more distribution, وصارت عندي الكينيلونز واللي هم أو الكينيلونز that have a fluorine at carbon 6 أو الفلوروكينيلونز, in terms of their spectrum of activity, they were they were, let's say, very successful in treating systemic infections. Later on, بس نحكي عن different generations of the quinolones. We will talk about in the first generation اللي هم nalidixic acid والsinoxacin for reasons where, let's say, because they do not have a fluorine, the penetration through the cell membrane بيكون عندي أقل, فعشان هيك their action is limited to where they distribute mostly واللي هي بالurine. Okay? Same thing for carbon number 7. Of all the substitutions they've tried على carbon number 7, الoptimal إنه يكون عندي إيش على هاي الكربون. What is this ring اللي موجودة على carbon number 7? How many atoms constitute this ring? 6. Okay? How many heteroatoms there are? 2. اللي هم those 2 nitrogens. All right? This specific ring بنسميها إحنا, أو is it aromatic by the way? لا, okay? يعني looking from the geometry of the atoms constituting this ring, كلهم طبعا except for this one, كلياتهم sp3 hybridized, okay? This ring in particular إحنا we call it a piperazine ring, okay? طيب أي atom اللي مش sp3 hybridized? This nitrogen that is connected to carbon 7. طب ليه؟ ليش مش sp2 hybridized? Yeah, because of the resonance, all right, with the carbonyl, it necessitates إنه اللون pair of electrons يكون موجود عندي على a p orbital parallel to those أو to this, let's say, aromatic system. So that is why it's sp3 sp2 hybridized, and if you look at its geometry, كل الاتاتشمنتس اللي حوالين هاي النيتروجين are planar. Okay, so having heterocyclic rings attached to carbon number 7 gave rise to optimal activity. The distribution of the drug enhanced, the penetration through the cell membrane enhanced, وطبعا parallel to that, the spectrum of activity زادت عندي. Okay, we will talk about that later. طيب, if you look at this ring, is it forming any interactions inside the binding site? Yeah. Do you see any kind of, yeah, all of those dashed lines between the atoms of this ring and let's say the backbone of the DNA gyrase, nucleic bases, all of those will also enhance the binding affinity of the drug to the target. Okay, طيب, nitrogen number 1. Let me rotate the drug حتى إنكم تشوفوا بشكل أفضل. Nitrogen number 1, which is this one in here. إيش في عليها؟ Cyclopropyl, yes. Now, they found out إنه one of the best substitutions اللي تكون موجودة عندي على هاي النيتروجين small alkyl groups such as methyl, ethyl, isopropyl, وأفضلها الcyclopropyl. Okay? For reasons mostly related إنه high alkyl groups would give rise to more interactions inside the binding site. Okay? هلا other kinds of substitutions that gave rise also to enhancement of activity, and يكون عندي, let's say, a 2,4-difluorophenyl ring attached to nitrogen number 1. Even though this substitution led to enhancement of activity, لكن after the introduction of those drugs in, let's say, into the market, they gave rise to serious side effects, such as, for instance, في حالة التيمافلوكساسين that have a 2,4-difluorophenyl ring attached to nitrogen number 1, it gave rise to hemolysis and renal failure. That of trivafloxacin gave rise to severe liver toxicity. هلا مش ضروري انكم تحفظوا exactly ايش هي side effects associated with those two analogs of fluoroquinolones, but all that matters انكم تعرفوا انه the two analogs that they were synthesized and FDA approved gave rise that have a 2,4-diphenyl ring attached to nitrogen number 1 gave rise to very serious side effects which led to withdrawal of those two drugs from the market. Okay? طيب. Another thing we need to talk about اللي هي one of the analogs that gave rise to improvement and enhancement of potency and also the spectrum of activity is attaching the substituents on atom أو خلينا نحكي in particular carbon number 8 and nitrogen number 1, which gave rise to ofloxacin. أو an example of such analogs اللي هو ofloxacin. Okay, where I have a third ring that is attached to the pyridone and the benzene ring. تمام؟ طيب, what is this? What is this substituent? Yeah, specifically, what is the name of this chain alkyl substituent? Methyl, بالضبط. It's a methyl. Yeah, ما هي سؤالي. Why is it represented using a zigzag line? When you see such representation of organic molecules or organic compounds, what does this zigzag line indicates? No, it's methyl. لا, it's لا.
ممكن تكون باتجاهنا وباتجاه الشاشة.
بالضبط. It indicates, let's say, the trajectory. هلا لما يكون ال trajectory defined أو هاي ال attachments أو this method for instance pointing towards us, احنا ايش اللاين اللي بنستخدمه؟ A solid wedged line. Okay, if it's behind the screen or behind the plane of the screen, we use a wedged line to represent that. Okay? طيب. معناها إنها هيك وهيك. Ofloxacin is actually a mixture, okay, of both stereoisomers. هلا how many يعني this means إنه هاي الكربون بما إنه عليها 4 different attachments إنها a chiral center, okay? Are there any chiral centers in the molecule other than this carbon? Is there? شو رأيكم? Yeah, that's the only chiral center in this molecule. طيب, انتوا definitely بتعرفوا الرول regarding the number of stereoisomers depending على الchiral centers اللي موجودة عندي بالmolecule, which is 2 to n. N stands for the number of chiral centers. So for this molecule, 2 to the power of 1, بما انه انا عندي only one chiral center, معناها the maximum number of stereoisomers for this molecule is 2. Okay? So for this molecule, we have 2 possible stereoisomers that we designate them as R or S. Okay? Ofloxacin is a mixture of the S and R stereoisomer. Okay? هلا لو كانت النسبة 50 to 50 شو بنسميه such a mixture? Racemic mixture. Okay? طيب هلا definitely إشي مر عليكم for sure بالأورجانيك بميديسينال 1 وميديسينال 2 إنه الactivity in between the stereoisomers is different. Definitely different. طب do you know why? Yep. Because for those drugs that bind in particular the enzymes أو حتى كمان receptors, the building blocks of those molecules are amino acids. وإحنا كلنا بنعرف إنه الامino acids الألفا carbon is a chiral center. الامino acids are actually, let's say, برضو may have more than, أو let's say at least 2 I wouldn't say at least يعني هلا بكل السايد chains ولا في side chain فيها let's say a chiral center. ف for amino acids I only have 2 possible stereoisomers. Okay? هلا البروتين سواء كانت enzymes or receptors that are made of chiral amino acids, okay, أو enantiomerically pure amino acids لأن also بنعرف إنه there is one abundant stereoisomer of the amino acids in our, let's say, bodies. فعشان هيك الريسبتورز والانزيمز احنا بنعتبرهم chiral molecules. Being chiral معناها they would favor binding to one stereoisomer over the other, أو إنهم بيرتبطوا ب one stereoisomer بس مثلا ما بيرتبطوش بالother stereoisomer. Okay? This means إنه if I would separate الofloxacin أو if I would separate الenantiomers اللي موجودين بالofloxacin, okay, and measured the activity, هل راح تختلف their activities relative to ofloxacin and their activities relative to each other ولا راح تكون the same؟ أكيد راح تختلف. طيب بتتوقعوا إنه يعني for sure one of the stereoisomers راح تكون الactivity له أعلى. هلا more active stereoisomer relative to ofloxacin شو بتتوقعوا؟ يكون more active ولا less active؟ Yeah, definitely more, okay? Because the more active stereoisomer relative to ofloxacin, ofloxacin has, let's say, in its mixture أو in its constituents أو بالدوز اللي أنا راح أعطيها, the other stereoisomer والactivity له راح تكون كثير أقل. So that is why there is variation. هلا between the two stereoisomers of ofloxacin واللي هم ال R أو ال S, the S isomer, which is called levofloxacin, that have this specific configuration at this chiral center, is almost 2 times more active as relative to ofloxacin. وما بين ال R وال S, ال S is 8 to 128 times more, let's say, active. Okay? هلا such a large range بالactivity ما بينهم is due يعني it represents the variations with different strains. يعني بالآخر different bacterial strains have different isoforms of DNA gyrase، وبالتالي البايندينج affinity from one strain to another بتختلف. فعشان هيك ما بين ال R وال S isomer there is somehow variation بالactivity that ranges from 8 to 128 times relative to the other less active stereoisomer. Okay? So يعني مش موجود عندكم هالسلايد بالnotes, but it represents, let's say, different strains of bacteria where they've measured the activity of ofloxacin and that, let's say, of the S and R stereoisomer. And if you would look at the minimum inhibitory concentration, it ما بين ال R وال S دائما الآسفة ال S راح تكون عندي, let's say, أعلى, لكن ال variation بيختلف from one bacterial strain to another. عشان هيك لما تشوفوا 8 to 128, this is the explanation for it. Any question about the structure-activity relationship before we move on to the chemical properties of الquinolones? هلا بما إنه the planarity of the carboxylic acid and the ketone is what enables those drugs to chelate with manganese inside the DNA and DNA gyrase complex, okay? It also enables the quinolone to chelate with anything, سواء كان drug أو حتى food that has metal, or metal ions in particular, such as مثلا milk that has calcium, other medications that has, let's say, those counter ions in their preparations, magnesium, zinc, and so on. Okay? هلا برأيكم such a chelation كيف ممكن يأثر على الدرug in terms of absorption? What do you think? راح يكون عندي الابزوربشن جدا أقل. That is why those medications, when taken, or this fluoroquinolones, when taken, they should not be co-administered with either milk or حتى any drug that does have such transition metals or metal cations. Okay, they should be taken, let's say, at least 2 hours apart from each other. طيب.
لا بكونوا تشارج يعني.
عفواً. هلا عشان نفهمها 100%, I will explain it لما احكي عن الزويتر ions. Okay? I will get back to this انه ليش عندي بتقل الابsorption when I explain how the Zwitter ion species may help, او انه لما عملنا الquinolones in the form of Zwitter ions, how it helped the penetration through the cell membrane. Okay? I will get back to this بعد هالسلايد. But before that خلينا بس نحكي عن الأسيديتي of the carboxylic acid. طيب البنزويك acid, where I have a benzene attached to a carboxylic acid. كم تقريبا ال pKa له؟ Does anyone know? لا. تقريبا in the range of 4.
4.
Yeah, in the range of 4. Okay? That of carboxylic acids in fluoroquinolones أو الquinolones, برأيكم, by looking at what surrounds, let's say, that carboxylic acid, how it is drawn in here, برأيكم هل الأسيديتي رح تكون أعلى ولا أقل؟ أقل. ال pKa بهاي الحالة رح تكون أعلى من 4 ولا أقل من 4؟ أعلى. Okay? Yes, بما أنكم you've judged that the acidity will be less, ال pKa رح تكون عندي أعلى. ال pKa is 5.6 to 6.4. طيب. هلا where is the acidic atom بالcarboxylic acid? Yeah, الatom. لا. Yes, it's the proton. Yes, due to the high polarization of this bond, تقريبا this proton, it has almost, let's say, or its empty orbital is ready, or its orbital is almost vacant, ready to be, let's say, to accept electrons from any base. تمام؟ طيب. هلا what other things that contribute to أو اللي إحنا usually بنستخدمها أو بنفكر فيها when considering acidity, أو if I have, for instance, more than one acidic compound and I need to compare between them. إيش ال other factors اللي أنا بفكر فيها؟ أو المين factor اللي أنا بفكر فيه اللي أحكم من خلاله على a relative acidity between different compounds.
pH؟
لا. definitely الاttached groups واللي بتأثر على بالضبط. Yep. It's طبعا besides the polarization of that bond, how easy it is to break this bond. Okay. برضه بفكر ب relative stability of the conjugate base. هلا if this proton is to be abstracted, this is the conjugate base that will be formed. تمام؟ طيب anything that will increase the electron density على الcarboxylate will increase or decrease the acidity? Increase, okay? Anything that will lower electron density على الcarboxylate رح يزيد من stability of the carboxylate وبالتالي بيزيد من chance for the carboxylic acid to dissociate into the carboxylate. تمام؟ طيب هلا conjugate base, all right, anything that will increase the stability of the conjugate base will let's say increase the acidity. تمام؟ وفور شور ال pKa عندي راح تقل. Anything that lowers the stability of the conjugate base واللي أنا بحكم عليها من خلال إنه electron density is it localized، هل في إشي عم بيزيد من هاي electron density ولا لا؟ أوكي؟ إحنا عم نحكي عن نفس functionality where the negative charge is delocalized, let's say ما بين هاي الأكسجين والcarbonyl oxygen. Now anything that lowers the stability of the conjugate base would lower the acidity و consequently ال pKa عندي راح تزيد. طيب relative to a benzoic acid, just give me a minute. Relative to a benzoic acid معناها إنه this carboxylate that forms in quinolones the stability له versus this one is less. معناها في إشي عم بيعطيه electrons ولا بياخد منه electrons؟ عم بيعطيه electrons، عم بيزيد من النيجاتيف تشارج، عم بقلل من الاستابيليتي وبالتالي بقلل من الاسيديتي. طيب what is let's say how can you think of what is adding electrons to this carboxylic acid or to this carboxylate? In nitrogen, okay? This nitrogen in here, if you think of it, we have that lone pair on the oxygen can donate electrons and I can reach those electrons can reach all the way to the carboxylic acid. يعني هاي النيتروجين via resonance it's donating electrons to the carboxylic acid بالتالي عم بتقلل من the stability of the conjugate base وبتقلل من acidity عشان هيك ال pKa عندي زادت. تمام؟ طيب there is also a very important factor based على كيف الستركتشر عندي مرسوم. Yep. So that hydrogen يعني احنا حكينا before إنه acidity is due let's say to this proton being also or its electrons are actually being withdrawn. هلا هاي electrons of the hydrogen being withdrawn معناها إنه هاي البوند ما بين الأكسجين والهيدروجين relatively is weak. تمام؟ يعني in other words the acidity is measured by how weak this bond is or how easily I can abstract that proton. The structure in quinolones where I have the carboxylic acid beta to it carbonyl معناها إنه ممكن يكون في عندي مجال تتكون intramolecular hydrogen bond interaction ما بين this proton of the carboxylic acid والoxygen of the carbonyl. Okay? معناها إنه أنا هالهيدروجين هلا صارت بدل ما هي مرتبطة ب1 oxygen هي عم مرتبطة ب2 oxygens وكأنه في 2 atoms are anchoring that proton بحيث إنه يصير صعب هلا على هالبروتون تنكسر رابطته let's say and to be dissociated from the carboxylic acid. So that's another factor that contributes to the increased pKa or lowered acidity of the carboxylic acid in quinolones relative to benzoic acid أو حتى aliphatic carboxylic acids. تمام؟ All right. هلا again we've already mentioned إنه later generations of quinolones where in particular they had a hetero ring attached to carbon number 7 where I have an ionizable group. اوكي. هلا صار الكمباوند at physiological pH may bear a negative charge and a positive charge at the same time. What do we call such molecules? Zwitter ions. Okay. هلا صح you may think إنه لما يكون أنا عندي two ionizable groups where one is positive or one أو let's say two ionizable groups in general معناها أنا البولاريتي بالووتر راح تزيد اللايبوفيليسيتي راح تقل بشكل كبير كثير فممكن أتوقع إنه البنتريشن through the cell membrane يقل بشكل كبير right لكن there's a paper that has explained the case for fluoroquinolones where when the fluoroquinolones were converted into Zwitter ions لما صار في عندي two ionizable groups السيستميك distribution زاد بشكل كثير أفضل. Okay. هلا the explanation is the following. the major ring system أو let's say the central part أو core structure for this molecule is planar. Okay. Which means إنه هاي molecules can stack on top of each other where the piperazine is that will be positively charged المولكيول اللي بيكون stacked on top of it راح يكون من جهة الكربوكسيليك acid. Okay. The ability طبعا due to planarity of this ring system the ability of those functionality to be right let's say opposite to each other معناها راح يصير في عندي intermolecular ionic interactions واللي راح تقلل بهاي الحالة بشكل كبير من polarity of let's say of such aggregates. And when the molecules of the quinolones aggregate in that manner, this will make it easy for those molecules to penetrate now through the cell membrane. عشان هيك الديستريبيوشن عندي صار أفضل مقارنة بالquinolones اللي فيهم one ionizable group. يعني صح احنا ضفنا بالجهة الثانية another ionizable group لكن الديستريبيوشن صار أفضل لأنه simply هاي molecules can stack on top of each other where the positive will be close to the negative and vice versa meaning إنهم رح يصير في عندي intermolecular hydrogen bond interaction they will aggregate بيلغوا charges بينهم وبين بعض which will facilitate the penetration of the drug through the cell membrane. Okay. طيب. alright. يعني مش رح أطول عليكم كثير. few slides left. هلا بالسلايدز عندكم إذا كان في أي توسع من ناحية إنه الفيرست جنريشن والسكند والثيرد مش ضروري إطلاقا تميزوا ما بين second, third and fourth generation for الquinolones. All that matters to us تميزوا مين الفيرست جنريشن ومين الليتر generations. Okay. The only members of the first generation اللي هم الفيرست let's say prototypes of quinolones إن الدكسيك أسيد والسينوكساسين. هلا بما انهم فيهم فقط a one ionizable group الwater solubility لهم عاليه البولاريتي عاليه this is let's say led انه بصير لهم concentration mostly بالurine that is why their use is limited for treating urinary tract infections. هاي فقط اللي بدكم تعرفوه regarding the first generation quinolones. As for anything else that has a fluorine and a hetero ring attached to carbon number 7, okay, هدول اعرفوا انه كلياتهم later generations relative to the first generation. انكم تميزوا مين second و third بالميديسينال لا، اظن بالفارماكولوجي بيطلبوا منكم such information، ولو طلبوا يعني احنا definitely we will not ask you to differentiate between them. Okay, all you need to know انه those let's say analogs or those derivatives of quinolones relative أو حتى to be more specifically fluoroquinolones relative to nalidixic acid with sianoxacin, these have much better distribution. That is why they can be used for treating systemic infections. Okay? Any question up to this point regarding the quinolones? تفضلي. أنا والله نسيت أدور عليه بس I will have that in mind و if I find anything بخبركم عنه for sure. Yes. طيب. نحكي فقط عن let's say a number of miscellaneous drugs very quickly، وإن شاء الله وبهيك بنختم محاضرة اليوم. المحاضرة الجاية إن شاء الله بنبلش في البنسلينز. Okay, those three drugs that we need to talk about اللي هم nitrofurantoin, metronidazole وtinidazole. All you need to know in those nitro compounds are linked to a heteroaromatic ring. In the case of nitrofurantoin, it's a furan ring. في حالة المترونidazole والtinidazole, as the name indicates, it's actually an imidazole ring that replaced the furan ring. Okay, the rest of the structure you don't have to worry about its specifications. هلا حتى كمان الميكانيزم اوف اكشن مش راح تنسألوا عنها، لانه those compounds, what is known about them is that they interfere with DNA and RNA synthesis. How they do that, what targets they bind to exactly, it's not well established. فعشان هيك all you need to know about those medications or those drugs is that they have a nitro group bound to a heteroaromatic ring. هلا an extra thing for metronidazole or tinidazole إنهم these are actually prodrugs. They need to be bioactivated, and their bioactivation occurs via reduction of this ring acid, reduction of this nitro group into what? If you fully reduce a nitro group تحول لإيش؟ Yep, a primary amine. Okay. آخر واحد رح نحكي عنه اللي هو الميثينامين. Methenamine that has this structure is also a prodrug. Okay, does not bind to a target. Its activity is due to generation of this molecule, which is what? CH2O. لو سألتكم إنه if I need to draw this structure كيف أرسمه؟ What is the functionality of this compound? An aldehyde. Do you know the specific name of this aldehyde? Formaldehyde, yes. Formaldehyde, when generated from methenamine, that's the one that is responsible for, let's say, killing the bacteria or for its antibacterial activity. Okay? I'm very interested in نعرف how this happens, or how the decomposition of methenamine gives rise to the aldehyde, and what is this other molecule? NH3, ammonia. Okay, like 4 and 6, what does those numbers mean? The number, yeah, of molecules or moles generated from each molecule or mole from methenamine respectively. تمام؟ طيب هلا this process happens only in acidic media. In UTI or urinary tract infections, the pH of the urine drops from normal. يعني هو already أصلاً slightly acidic. In recurrent infections, the pH even drops more. هلا when methenamine is administered, it will specifically decompose in urine due to the acidic conditions in there. طيب, can you think of مثلا لو سألتكم propose a mechanism for the decomposition of methenamine to ammonia and formaldehyde? شو أول step ممكن تفكروا فيها؟ خلينا نحكي by default. Look at the two structures, an acid and methenamine. It's a basic molecule بالضبط. Those nitrogens are all tertiary amines. شو أول step راح تصير؟ protonation أو acid base reaction ما بين let's say البروتونز أو الهيدرونيوم ion and الميثينامين. لنفترض إنه صار في عندي protonation in here. Okay, for sure this nitrogen will now bear a positive charge. طيب, what do you think happens next? Okay, how do you think this happens? هلا الأمونيا وبنعرف إنه مصدرها أو النيتروجين بالأمونيا مصدرها من النيتروجينز اللي موجودة عندي بالميثينامين. Okay, والكربون for sure من ال6 كربونز اللي موجودة عندي هون. طب والأكسجين من وين برأيكم إجت؟ من الووتر. تمام؟ طيب, بما إنه هون الأكسجين is connected to the carbons, بصير في بالضبط. Okay, طيب معناها إنه الwater here is definitely has attacked this carbon. طب ليش هاي صارت specifically بالacidic conditions؟ برأيكم؟ بالضبط. Yeah. هلا these carbons in particular to begin with, these are actually electrophilic because they pair a partial positive charge due to being connected to two heteroatoms. هلا لما one of the heteroatoms becomes protonated, where it will bear a positive charge, it will highly withdraw electrons inductively from this carbon, making it even more electrophilic, susceptible to attack by weak nucleophiles such as the water. But once one of the nitrogens is protonated, the water molecule will now attack this carbon. Okay, let me draw the mechanism. فقط راح أرسم, let's say, part of the structure. Don't forget for sure, خليني أرسمهم معلش هيك بطريقة شوي distorted, إنه هاي carbons أو all of those carbons, they do have two hydrogens attached to them. هلا when the oxygen attacks الكربون مقابل هاي البوند اللي بدها تتكون رح تنكسر عندي another bond. أي أضعف بوند موجودة عندي؟ ما بين الكربون والنيتروجين اللي already positively charged. فبتنكسر هاي البوند والelectrons will now reside on the nitrogen. Okay, where it will become now neutral again. And that carbon is now connected to الأكسجين. راح أختصر إنه when it's already أو when having two protons راح يكون عليها positive charge, later on a proton swap اللي happens in media very quickly may one of those protons will be, let's say, removed وترجع عندي هاي الأكسجين in neutral. هلا a carbon that is sp3 hybridized connected to an oxygen and a nitrogen, yes, it's, let's say, highly أو relatively speaking unstable. فاللي راح يصير عندي إن الأكسجين with its lone pairs will form a double bond بينها وبين الأكسجين وراح تنكسر الباند بين الكربون والنيتروجين. طبعا what facilitates that إنه هاي النيتروجين ممكن يرجع ويصير لها protonation in acidic media very easily, which would weaken the bond even more and more. فشو راح يتكون عندي؟ This is the carbon, the two hydrogens اللي عليها, and this is the double bond with the oxygen. Okay, this is how decomposition occurs. طبعا this process occurs for all of those carbons which will eventually give rise to 6 molecules of the aldehyde versus 4 of the ammonia. تمام؟ مجرد ما أعرف إنه الأمونيا بصير لها protonation, this will help you to memorize إنه هالcompound رح يصير way more electrophilic, susceptible to attack by weak nucleophiles such as the water. Any question up to this point? طيب. Yes, for sure. يعني as far as I know, methenamine is formulated as enteric coated tablets. Yeah. So that, let's say, to overcome being exposed to the acidic media in the stomach. برضه راح أتأكد. يعني this is what I know so far, but for sure I will make sure إنه this is how it's administered, and I will يعني get back to you إن شاء الله المحاضرة اللي جاي. Okay. Any question up to this point? Alright. يعطيكم ألف عافية يا جماعة، وإن شاء الله المحاضرة الجاية راح نبلش في البنسلينز. اللي موجودين أونلاين، في أي حدا عنده أي سؤال؟
لا دكتورة.